Now, before we discuss Mendeleev's periodic table and a modern periodic table, we should know the meaning of the term periodic table. Now, periodic table means a chart of elements prepared in such a way that the elements having similar properties occur in the same vertical column or group. Here we have the word periodic. What do we mean by periodic? Why it's called periodic? Periodic actually means repetition at regular intervals. Okay, so it's called periodic because what happens when elements having similar properties are there, the elements having similar properties are repeated after certain intervals or after certain periods, as we saw in the Newland's law of Octavius also. So it's called periodic because the properties are repeated after certain intervals, and it's called a table because the elements are arranged in the tabular form. So the chart of elements which are prepared in such a way that the elements having similar properties occur in similar vertical group is called the periodic table. Now, in periodic table, there are rows, horizontal rows, and there are vertical columns. Horizontal rows were termed as periods, and the vertical columns were termed as groups. Okay, so in Mendeleev's periodic table, which we are going to study, the elements are again arranged on the basis of the same thing, atomic masses, as the beginning of the as Dominier classified on the basis of atomic mass, Newland classified on the basis of atomic. Same thing Mendeleev also did. He arranged the elements on the basis of increasing atomic mass and also on the similarity of chemical properties. Now, what Mendeleev did, he took the formula of the oxides and hydrides formed by the elements as the basic property of elements for their classification in the form of periodic table. It means he saw that oxygen and hydrogen are chemically very reactive, and most of the elements combine with oxygen to form oxides and react with hydrogen to form hydride. So the elements having similar chemical properties form oxides having similar formula. They also form hydrides having similar formula, right? So what he did, he take the general name for the elements, he represent elements by the letter R, and he take the general formula of oxides and hydrides. Like we will see here in the example. See, if some elements form oxides having the same general formula, then they will have similar chemical properties. So he take the formula of oxide as his basis of classification. See, the elements lithium, sodium, and potassium, when they form oxide, when they react with oxygen, they form the oxide, lithium oxide, sodium oxide, and potassium oxide with the formula of this Li2O, Na2O, and K2O. See, the formula is almost similar. And for the elements, he represented elements by the letter R, and the formula, general formula, becomes R2O. And see, they all of the three have the same general formula, so it means they will have the similar chemical properties. Same goes with the hydrogen. If elements form hydrides, if they react with hydrogen and form hydrides, they have again the same general formula. And when the elements have the same general formula, what will happen? They will definitely have the similar chemical properties. Let's say, for example, lithium reacts with hydrogen, it will form lithium hydride. Sodium reacts with hydrogen, it will form sodium hydride. Potassium reacts with hydrogen, it will form potassium hydride. And see, the general formula is same, RH. And when they have the same formula, it means they will have the similar chemical properties. So he took these formulas of oxides and hydrides formed by the elements as the basic property of his classification of elements in the periodic table. So this was the base of his periodic table. Now see the Mendeleev's periodic table. Now, while working on the classification of elements, Russian scientist Dmitry Ivanovich Mendeleev found that when elements are arranged in the order of increasing atomic masses, the elements with similar properties occur at regular intervals. And he, based on this observation, he gave his law in 1869. And what was his periodic law? At that time, 63 elements were known, and his law was the properties of elements are periodic functions of their atomic masses. Now, what do he mean by this? He told that if elements are arranged in the order of increasing atomic masses, as you can see in this Mendeleev's periodic table, what happens? The properties repeat at regular intervals. See, there's a difference between Newland's law and Mendeleev's law. Newland told categorically that every eighth element has the same property as the respective first element, but he didn't say that eighth element or seventh element repeat this property, but he said that properties will get repeated after regular intervals. So this is the difference here. And he arranged all the then known 63 elements in the order of increasing atomic masses in horizontal rows, and in such a way he arranged these elements that the elements having similar properties came directly under one column, under same vertical column or group. As you can see here, suppose if I am taking this group, this column, the elements in this column have the same properties, and he arranged them in such a way that uh, that in a particular column the elements there have same properties. So he used similar properties to arrange the elements in a particular group. And what was that similar property? That was the similar formula of oxides and hydrides, which I discussed earlier. As you can see here, he has wrote the formula of oxides and general formula of oxides and hydrides here, and the elements which are falling in this group have the same general formula for the oxides and hydrides. So he used this property to classify his elements. Now, there he arranged the elements in the horizontal rows and in the vertical columns, and the horizontal rows, which were known as periods. There were 7 periods and 8 groups in his periodic table. These are here 7 periods and 8 groups in his periodic table. And out of these 8 groups, its groups are like this, vertical. And out of these 8 groups, the first 7 groups are the group of the normal elements, and this 8th group is a group of transition elements, which we will study in the further classes. And noble gases were not known at that time, so there was no group for noble gases in his table. Now the elements in each group, in each vertical column, are similar to one another in many properties. Okay, so it means similar properties are repeating periodically. It means he placed elements in such a way that the elements having similar properties fall under the same group. Okay, so there are 2 main features of his periodic table. One is the gaps in the periodic table. You can see here, gaps are left in his periodic table. Now, in order to make sure that the elements having similar properties fell in the same column, same group, Mendeleev left some gaps in his table, and these gaps were left, which were left for the elements not known at that time. And Mendeleev thought that these elements would be discovered later on, and he even predicted the properties of these undiscovered elements, unknown elements, by studying the properties of the neighboring elements. For instance, if this group is this space is left, this element is not known, he predicted his properties on the basis of his neighboring element, on the basis of boron here, on the basis of aluminum here. Okay, so he predicted their properties before their discovery. Okay, and the next important feature was wrong order of atomic masses. Again, for the same reason, to make sure that the elements having similar properties fell in same group, what he did, he placed somewhere few elements in the wrong order of their atomic masses. As you know that what was the law? Law was based on the increasing atomic mass. It means the lower atomic mass comes first and the higher atomic mass comes later. But you can see here, cobalt, it has the atomic mass of 58.9, and nickel have the atomic mass of 58.7. Which has a lower atomic mass? Nickel. So nickel should come before cobalt, but what he has done, he has placed cobalt before nickel. He has placed higher atomic mass before lower atomic mass, just because to make the properties similar, to make the elements fall under the same group, so that the properties should match. Same what he does, cobalt, why he did so, because he want cobalt, he want that cobalt should fall under the rhodium element under the column of rhodium element, because these two have the same properties. That is why he placed cobalt first and then nickel. Higher atomic mass first, then lower atomic mass. Okay. Now, Mendeleev's periodic table was of great help in the study of elements and their compounds.